Okay, that right there is a parallelogram. Why? What makes a parallelogram a parallelogram? Noah?
4 sides.
4 sides. Okay, that's any 4-sided figure, a quadrilateral. So we would just call a 4-sided figure a quadrilateral. So what makes the actual parallelogram? What characteristic does it have, Bridget?
Parallel sides.
It has all opposite sides are parallel. So that means that all these are parallel to each other. So these are parallel to each other, and these two are parallel to each other. Right, everybody?
Yeah.
Also, does it mean that they're equal, they're congruent, opposite sides are the same length as well?
Yeah.
Yep, absolutely. So you don't need to be writing this. Put your lids on your markers, guys. Just put them on. Okay? This is a parallelogram. Okay. This is a parallelogram. It has opposite sides parallel. So, you know, that's what makes, I mean, I could draw any 4-sided figure up here. Something like that. Right? I mean, that's a quadrilateral, I think. 1, 2. Yeah. That's a quadrilateral. But we don't call it any other special name because it's just a 4-sided figure. A parallelogram is a 4-sided figure, but it has another characteristic that makes it what it is, and that put the lid on the marker. And that is that opposite sides are parallel to each other. So how do I find the area of a parallelogram? This is learning target number 1. So I'll even write the learning targets on here. It'll be on the video so that you guys can review it if needed. Bridget?
Base times height.
Base times height. So first thing I'm going to do is I'm going to write parallelogram. This is all in your notes, by the way. And that is going to be area equals the base times the height. Now, who can remember what's special about the base and the height? Like, how do I know what the base and the height of a figure is? Yeah? Wait. Abid? It has to be at a right angle. So, guys, if I gave you this right here, and I said this was 5 meters, and I said this was 8 meters, and I said this was 5 meters, and I said this was 8 meters, and I asked you to find the area of that, what would you tell me? What would here, I'll zoom in so we can see it a little bit better. What is the area of that right there? Who can tell me what the area of that is, Brennan?
You can't find it.
You can't find it. Now, some people might think, well, I kind of tricked you guys right before spring break, right? And you guys thought the answer would have been 40, correct?
Yeah.
Okay, but we realized, no, it can't because the base and the height always has to form at a right angle, right? So as I look right here, is this right here going to be a right angle, guys? No, that's bigger than that's an obtuse angle. That's greater than 90, right? I gave this example when we went over this, but I'll give it again. But when you go to the doctor, you don't measure your height. You don't stand here and say, "Yep, measure me, please." You don't do that, do you? No, you stand up vertically as tall as you can with your if you measured the angle of your feet in the ground, it should be 90 degrees, right? Or you're not standing straight up and down. So this would be impossible. So we have to then, you usually see something like that that shows a true distance from the top of the parallelogram to what we call the base, the 5. Okay, everybody got that? Good? Okay. Yep.
I have a question.
Go for it.
So for the test, when's the test again?
It's not for a few weeks.
Well, if this is on the test, will there be a question where it's only you say that draw a line to make it perpendicular so you can find the area?
I mean,
Yes.
you mean, would I ask you to find the area of that right there?
No.
I could.
But then, like,
And you would put, can I do it?
well, wait, but can't you, like, find the area if, like, if also add in the sentence,
Well, but how you,
draw a
okay,
line?
but you can do this. How are you going to know what length that is? Measure it? There's no way to know.
Answer that question.
There's no way to know what that length is. Okay, that's what I'm trying to say. So that's the formula. Area equals base times height. That is not a new formula. You've learned that formula a long time ago. Only you might have said length times width, but it's the same difference. Right? Okay. What is this shape right here?
Rectangle.
That is a rectangle. Now, does that have the same characteristics of what a parallelogram has?
Yes.
Does it have opposite sides parallel, guys?
Yeah.
Does it have opposite sides congruent or the same length?
Yes.
Yes. So why do we call this a parallelogram? Why do we call it a rectangle? Like, what makes it a rectangle? What special thing do we know about that thing that makes it something special? And why can't I just say, hey, parallelogram? Luke?
Because it needs its own special name because it's a quadrilateral and a parallelogram.
Well, but so is this.
Yeah.
This is a quadrilateral.
It's both.
You're right, it is. But then, if it's both, this is both. So why don't we just say, hey, this is just a parallelogram right there. Why don't we just call it that? There's something special that it has that makes it a little bit different. It's a little characteristic. Andrea? You got it. So that's basically what the difference is. So a rectangle is just a special type of parallelogram, but it has, instead of it just being only has the characteristics opposite sides are parallel and congruent, it also says that all four angles inside of there are 90. This would not have that. If this one up here has all angles that are 90, then we would call it this. Do you guys understand that? Okay. All right. And then we can go a step farther and we can go to squares. And then a square is a special type of this where what? All the sides are the same. Does it still have the same characteristics of the rectangle? All four 90s? Does it still have all the characteristics of the parallelogram? Opposite sides parallel, congruent? Okay, so that's kind of how it works. So you just got to know the formula. Okay, I will probably try to trick you at some point today in thinking that like this is a height. Is that a height?
No.
No, it's not. Okay. What's the other shape that we learned about right before break, the week before break there? What did we learn about, Kylie? We learned about triangles. Now, what makes a triangle? What are some things that make up a triangle? Like what makes a triangle, I guess, is what I'm trying to say. What makes a triangle a triangle? Yes?
3 angles, 3 sides.
And all the angles add up to 180. I thought you'd say that. Anyway, yes, a triangle, it has 3 sides, obviously. So it's not a quadrilateral. Manny, pay attention. Okay, it's not a quadrilateral. It's a triangle. It's 2 different things, 2 completely different things. This has 3 sides. Who can tell me what the area formula of a triangle is? Steve-O?
Area equals 1/2 times base times height.
You got it. Okay. So, got to know these 2 formulas, right? There's the first formula. That was learning target number 1. This is learning target number 2, right? Now, when I have a triangle, if I gave you this triangle right here, and I said, I need you right now to find the area of this triangle, and I said this was 8 meters, and I said this was 7 meters, and I said this was 6 meters, what's the area of that triangle? Yeah? Well, there's certainly an area, but it's not possible, right? That's why I have you put 0 in your clicker, which is fine, because that means, that we've kind of learned that means impossible. But it certainly has an area, right? I mean, if it has 2 different dimensions, which we know it does, we can look at it and see that. It obviously has an area, but we cannot find it. It's not possible to find it. Got that? So, most of the time, this is what it looks like. Okay? I'll give you something like this. But please pay attention, because I want you guys to understand this. And I said that this was 4. What is my base and what is my height of this triangle? What is the base and what is the height of that triangle? Some different people. Let me see. Lesnar, go, my man.
8 and 4.
8 and 4, right? Because what do they meet at?
Right.
A right angle. Good. A right angle. Now let's go at this a little bit differently. This is where it gets maybe a little bit more confusing. What is the base and the height of that triangle? This is where a lot of people would miss. Corey.
7 and 6.
7 and 6. Now, I have a feeling if I'd have asked everybody to put that in their clicker, I have a feeling there's some people that would have still thought this was the base. You guys have gotten in a good habit of knowing that the height is a dotted line usually, but that really has nothing to do with it. It's not going to be 8 and 6. It's not. You guys get the word base confused because what is the base? What does base mean in our language? Bottom. So you guys automatically think, well, 8's the base. No. It's all about where the right angle forms. Like Corey said, because this right angle forms right there, that means that this is the base, this is the height. You guys understand that? Okay. Let's go another one. What if I said that, and I said this was 2? What is my base and my height of that triangle? Page 6 and 2. And obviously that's not the bottom of it. But can you take any shape and flip it and do anything you want, move it around? Yeah, I could move this thing. I could grab it and I could flip it over top of itself, and I could make that the base. You know, I could make it that. See what I mean? I won't, but I mean, that doesn't really make a difference at all. Okay? So that's a triangle. So we would do 1/2 times base times height. And you guys are all well aware that every triangle can be made into a parallelogram, right? And that's why you do 1/2 times base times height. Because the area of this is going to be the same area of the pieces that are cut off. That's why it's 1/2 times base times height. Everybody got that? We'll talk more about that later. We'll get more into it. Okay, now, we've done those two. That's your little recap of what we did before spring break. Now, what shape did we learn about last night? What did we learn about last night? What shape? Caden. We learned about Uncle Trap. We learned about the Uncle Trap. But what makes a trapezoid a trapezoid? Yes, it's a quadrilateral. Yes, it has 4 sides. But it's got something special about it. Brennan.
There's only one set of parallel lines.
Yep. It only has one set of parallel sides. So the most general trapezoid that you guys know of looks like that, right? And you know that this is parallel to this. That's what it usually looks like. But let's just make sure we all understand that if I were to draw this same trapezoid here, oops, and I were to take it and flip it, is that still a trapezoid there?
Yeah.
Yeah, absolutely it is. It's just, it doesn't make a difference. I mean, it's trapezoids. And again, a trapezoid is a trapezoid because why? Who wants to explain it one more time for me? What makes it a trapezoid? Lucy? Yeah, these two right here are parallel to one another, correct? Are these parallel?
No.
Clearly not. They're gonna cross at some point, obviously. Okay? What are parallel on this? Do you agree that this is parallel to this?
Yep.
Okay, good. Who can remember what the area formula for this is? Sammy.
Area equals 1/2 times height, parentheses, base 1 plus base 2.
Now, do you guys agree that that's a fairly challenging formula to try to memorize? Well, some of you might say not really, but let me ask you this. Is it harder than base times height?
Yeah.
Sure it is. So that's all I mean, Rachel. It's definitely harder than the base times height, 1/2 times base times height. There's more going on, and we're going to learn about where that formula comes from later. Okay, we'll talk more about that tomorrow a little bit, and then we'll talk about it in the coming weeks. But there's a reason that formula is what it is. Okay, and we'll talk about that later. How do I know what the height of a trapezoid is? Yes, I know you're going to say it meets at a right angle. Okay, that's fine. But let's think more a little bit differently here. How do I know what the height of a trapezoid is? All right, let's work backwards. Hold on. I'll come back to that. How do you know which one is the base 1 and base 2? Like, which sides makes up the base 1 and the base 2? Like, how do I know what those are? So there's my base 1. There's base 2. How do I know which sides are those, Abid? They're the two sides that are parallel, Bryce. They're the two sides that are parallel to one another. So when I look here, I say, okay, that's one of the bases, that's one of the bases. Do you agree with that? Because that's one of the parallel sides. This is the other base, this is the other base. See how I'm using colors to kind of show this? Now, does it really matter which one is base 1 and which one is base 2? No.
You said in the video you like to put the smallest one.
Yeah, usually I'll put base 1, the shorter one. I mean, but it does, and it's adding, so it's commutative. So really, this formula couldn't be written as base 2 plus base 1.
Yeah.
That doesn't matter because the commutative property. That's pretty basic. You with me? Okay. So we know the bases are always the parallel sides. Real quick, parallel. What's the real life parallel thing? What's the real life parallel object that you probably drive over every morning? Yep. Okay, lines on the road. That definitely is. There's a little bit better one that I think is easier, a little bit easier to visualize though. That one works. That works for you. Kylie? Yeah, that one would be too. That's not exactly the one I'm looking for, but no, I'm not saying that's wrong because that's beautiful. Noah? Okay, yes. Wow. Andrea? Yes, all those are beautiful parallel things. Yes, yes. Yes. Okay, that's the same as a road, guys. Doobie. Oh my gosh.
Concrete.
Oh my gosh.
Oh, I thought you said-
Bridget, please.
Speed bumps.
Speed bumps.
Railroad tracks. Oh my.
I knew it. I was just waiting.
I can't believe.
We don't fire them every day.
Okay, well, I do. All right.
You drive over railroad.
Okay, anyway, railroad tracks. I think that's just a good example. I thought you guys would get it quicker. You're the first class to not be the first. Like one person guessed it in the last 2 classes. Anyway, so you look here. There's my train tracks. Pretty easy. Forever and always, they got to be the same distance apart because that's how far the train is. Wide, or how the, you know what I mean? So, yeah. So, when you think about this, I'm going to use this example a lot when I'm talking about trapezoids. The tracks are the 2 parallel sides, so your 2 bases. Everybody understand that? Now, if I asked you to measure the height, or I'm sorry, if I asked you to measure the distance between the tracks, would it be okay, everybody look here please, would it be okay if you took a tape measure or a ruler or whatever, and you measured like that?
No.
Why? Why is that wrong? What? Explain it to me. Why? Thomas. It's sideways. It goes back to the same old thing. When you go to the doctors and measure your height, you don't stand on a slant,
It's not sideways.
or you don't stand on a slanted floor or something like that. You stand straight up on a flat floor so that you can get your true height, right? So this is the same thing. Would you guys all agree that if I were taking, let's just say a tape measure, and I was actually sitting it, wouldn't I have to sit it straight across, and wouldn't this have to be right angles here, guys?
Yep.
Yeah.
Yeah, that would all have to be right angles. Because that would give you the true length between those 2 train tracks. That is what the height of a trapezoid is. The height of a trapezoid is the distance between the 2 parallel sides. I'll say that again. The height of a trapezoid is the distance between the parallel sides. So we know the 2 parallel sides, that's your base 1 and base 2. The distance between them, how far apart they are, or they will be forever, is your height. Everybody understand that? What?
Since I missed out on the triangle part with the 180 degrees.
This formula only works for trapezoids. That's it. So if I go up and try to use it on a parallelogram, it's not going to work. Because which one's going to be your base 1 and base 2? There's 2 sets of parallel sides. Okay, you can't do it that way. It doesn't work. This only works for this shape. Everybody got me? So let me ask you a question here real quick. Is this right here, is this a height? Could that be my height of my trapezoid?
No.
Could this be the height of the trapezoid?
No.
No, none of those could be the height of the trapezoid. It has to be perpendicular. So that means, like this one, normally we again show the dotted line going like this. Just like that. That would be a height, right guys? That would be a height. This would be a height. Everybody got that? Are we good here? So remember, the base and the height always have to form at a right angle. That's no different. The only real difference here with this height is it's the true distance between the 2 parallel sides. It's still the height. It still meets at a right angle, but it's the distance between them, yes. Because of who? Sure. Blame this guy. Okay. All right. Here we go. Let's try one. Okay. Now, real quick. Actually, yeah. Let's try one real quick. The one thing I'm going to say though, before you guys start working, Manny, pay attention. What's the first step to finding area of any figure ever? Keegan. No. That's what everybody thinks. And even though that is technically the first step, there's a step before that you do and you don't even realize you do it. Yeah. You've got to identify the shape, which obviously then tells you which formula to write. So before you start here, you need to first of all identify what the shape even is. Is it a triangle? Is it a parallelogram? Is it a trapezoid? Okay, that's what you have to figure out. And then from there, you're going to have to write the formula. You're going to have to write the answer. You're going to have to write the units. Guys, all of these are worth 3 points. So I want you to think about that. If it's worth 3 points, how many things am I looking for? 3. That's the formula, whatever the answer is, and then units squared, meters squared, feet squared, inches squared. That's what I'm looking for. So go ahead and try this one. Go. Okay. So here we had everybody in the room put 30, which is good. One person put 15. Okay. Now, let's talk about my 3 points here. Please listen, guys. Don't keep writing. Don't be erasing. Don't be doing other things, even if you got it right. Just please hear me, okay? You've got to identify the shape. Now, that doesn't necessarily mean you have to write what shape it is. Okay, now, if you want to do that, more power to you. If that helps you process what you're doing, that's fine, okay? When you look at that, obviously it's a four-sided figure, so that makes it a quadrilateral, correct? But that's a special type, and that's a special type where the opposite sides are going to be parallel to each other and the same length, right? So what do we call an object that has two sets, or all the opposite sides are parallel to one another? Yep. We call that a parallelogram. And what is the area formula for a parallelogram? Yes, Sammy? Now, one thing that kind of is going to be a pet peeve of mine. I do not want you using a capital B. Now, I've kind of already explained to you why. Who remembers why? What is capital B? What formula do we use that for? It's like in the future. Next chapter. Alex?
For three-dimensional shapes.
For volume, right? Remember, we use volume equals capital B times H, but that's the area of the base shape. But I don't want to confuse you. Let's make sure we're using lowercase. Okay? So this can be a lowercase b, lowercase h, like that, right? Now it's about identifying the base and the height. The good news is, nobody used this. That makes me happy. Is that a distractor?
Yeah.
Is it going to help us find the area at all? No, because there's nothing there. Okay? The base and the height always has to form at a right angle. So here I know that the base and the height is 5 times 6. So I know my area is 30, and then it's got to be meters squared. So the 3 points here are formula, your answer, whatever you got as your answer, but then it's got to be meters squared, feet squared. It can't be just meters. It can't be meters cubed. Anything you have other than that is wrong unless you put square meters. Something like that. That's fine as well. Everybody got that? All right, let's try another. Let's go down to this one right. There you go. Go ahead. Find the area. Is there still 3 points here?
Yes.
Yep. So here is our answer to that question. So the correct answer was 42 and 35 hundredths.
Wait.
Okay, now I know a couple of you rounded. Guys, general rule though, unnecessary to round if it's only going to the hundredths. I mean, our rule has always been round to the hundredths anyway because of money. But so if it's already going to the hundredths, it's not necessary that you round to the tenths. Okay? Put that number and put that answer in. Now, if it goes to 8 decimal places, then round. But we always round to the hundredths, is what I've taught you to do. So I think this person right here, they just rounded 42 and 4/10. That's technically, they did it right, so they got it right. This person put 45.35. I have a feeling they just mistyped theirs. So it looks like there was 16 people that got it right. Now we had a bunch of people get 84.7. Now I know exactly where that answer came from. So let's talk about it. Now, please hear me out on this, because I'm once again going to give you a method that's going to help you. Okay? First of all, I've got to identify the what?
Shape.
Shape. What shape is it?
Triangle.
It's a triangle. It has 3 sides, 3 angles. That's the definition of a triangle. Correct? Quit writing and listen. I need to see eyes up here. Okay? So what is the area formula for a triangle? Yes?
Area equals base times height times
1/2 times base times height. And he said it, the way he said it was perfectly fine because multiplication is commutative. So that means he could say half times base times height. However he wants to say it. Base times 1/2 times height. That doesn't matter. This is just the way that I would generally say it. But the order in which you do it doesn't matter. Haley, be with me, please. Okay. Now, is there a distractor on this question? Is there a number up there that really isn't going to help us at all and it's just going to distract you? It's just going to get you to think maybe, okay, what do I do with this number now? Sammy?
19.
Yeah, 19. Obviously, I'm looking at 19. Now, if that were a base, I would have to see some sort of right angle. So let me ask you a question. If I knew this length right here, could this be the base and this be the height, guys?
Yes.
Yeah, it could, but I don't know that. So 19 is out of the question here. It doesn't help us at all. So for the most part, from what I saw, I see that all of you either got, most of you anyway, either got 42 and 35 hundredths, or you got 84.7. Those are the two things that I saw. Now, I can tell you where 84.7 came from. Watch. 84.7 is those people did this formula. Area equals base times height. Is that a parallelogram?
No.
No, it is not. It's not a parallelogram, so you wouldn't do the parallelogram formula. So when you do this, they did 11 times 7.7, and that's where they got 84 and 7/10 kilometers squared. That's where they got that. Right? Okay, but actually, by the way, just a quick question for you. Is that an algebraic expression right there? Yeah, it is. What was the first step to when we were going to evaluate algebraic expressions? What was that first step that I made you do every single time when we did this several months ago? What was the very, very first step, Lucy? Turn that algebraic into a numeric. So watch what I do here. This is an easy step. It might take you an extra 7 seconds to do, but it's going to keep you from missing some of these. Watch. I bring down 1/2 because that's a constant, correct? 1/2. What is my base of this triangle? What's the base length? I see the right angle right there. I'm just extending this out there. That's it. It's going to be 11 times 7.7. Okay? Now, real quick, I don't want to confuse you, but we already know that 11 times 7.7, isn't it this, guys? Hello? And then wouldn't I just be doing half of that, guys?
Yeah.
So what is the same as doing half of something? Dividing by 2. Remember how division is just multiplication? Good, exactly. Okay, multiplying by half is the same as dividing by 2. It's the same exact thing. Okay? So here's what I want you to do though. When you do these, you guys are trying to do these in multiple steps. All you have to do is type this right here into your calculator. You can do 1ABC2, or you can do 0.5, however you want to do it. Just type it in. 1ABC2 times 11 times 7.7. Has everybody got me? I'm going to see who is just listening to that here in a minute when I do the next one. Okay? You're going to end up getting 43, is that right? 42 and 3/500 kilometers squared. Here's my 3 points. Formula, answer, units. Right? Formula, answer, and units. Okay? Let's go on. Okay. First of all, help me to identify, what am I looking at here? What is this thing? That is a trapezoid. Now, for those of you that might not have that formula memorized yet, I'm going to give it to you, but you need to know it by tomorrow. That's got to be your mission tonight. So, area equals 1/2 times the height times base 1 plus base 2. Let's see who can do this now. Guys, again, just turn the algebraic expression into a numeric expression. Just bring down everything you see there and then type in that whole expression with the parentheses and everything. Go. Okay, today is just practice, guys. That's why I'm going over it today nice and slow. But you guys got to be with me. Okay? Watch how I do this. Please see this. I'm just trying to simplify it for you guys. Here I have an algebraic expression. Everybody agree? Now 1/2 is just a constant. That's got to come down automatically. Now, how do I know which sides are the bases? How do I know what are my bases of a trapezoid? You just can't pick the one on the bottom, the one on the top. You can't do it that way. What technically are the bases, Lesnar? It's the two sides that are parallel to one another. So if I look up here, are these two going to be parallel to each other, guys? No, they're not parallel. The only two that are parallel are here and here. So do I know that those have to be my bases, guys?
Yes.
So I know right away that I can go ahead and in parentheses, I'm going to go ahead and put in 2.3 plus 7.9. Those are easy to identify. Now, what is the height of a trapezoid? Of every trapezoid? What is it? Abid? No. Well, yes. Yes, it is. Okay. Yep. It's the distance between. So if I'm saying that this is base 1 and this is base 2, that means the distance between them would be from there to there, right? Brennan? The distance between them would be from there to there, so I know that that is my height. So right there. Now, this is the part that you guys are, like, when I ended here, you guys will see all these different answers. And a lot of them are pretty close. Like here, I think this person might have just mistyped, I don't know. But we got like 20, 18? I mean, that's close. So that to me makes me feel like they were just trying to add it do it in separate steps or whatever. Okay, but that is the correct answer. Most of you got it, but we have some other kind of crazy answers. And my thing is when you guys get to this step right here, this is what I want you to just type that into your calculator. That's all you have to do. Okay? Like I said, you guys have already shown me you know how to add decimals. You've already shown me you know how to multiply. That stuff's not part of what we're trying to accomplish. We'll still do those skills, but not here. I want you guys just to make sure you're understanding area, and that's what we're practicing. Everybody understand me? So when you type that in, remember you can do 0.5 or 1 ABC2 times 4.6. Do you need to have the parentheses?
Yeah.
Absolutely you do. Got to have the parentheses there. When you do all that, you will end up getting the correct answer of, what did I say?
23.46.
23.46, and of course it's got to be meters squared. So my 3 points here, guys. Look, 1, 2, 3. Everybody got that? Good? Okay, let's do another one. I'd like you guys to please find the area of this question. Okay, that was kind of a trick here. Okay, first of all, what shape is it? That's the first thing. Yeah, it is a trapezoid. Now this one looks a little bit different, doesn't it?
Yeah.
It does. It has a little different look to it because it's spun. Usually we see the trapezoid like the one we previously just did. What is the side length of one of the bases? Like one of the parallel sides. Like, give me one of the lengths. Doobie? 32. Would you agree that that right there is a base?
Mm-hmm.
Yep. So that means if that's a base, then this has to be the other base because you're saying it's parallel to the side opposite of it. Right? Okay. So, as I look through this, I know my formula is area equals 1/2 of the height times base 1 plus base 2. Okay. Do I know base 1?
Yes.
Yes.
Do I know base 2?
Yes.
Do I know that 1/2 always remains?
Yes.
Do I know this h?
No.
What, but why isn't this the height?
Because
Right, right. Yes.
Because it's not a 90 degrees angle.
A 90-degree angle. There's no 90-degree angle. Well, I mean, there is, but this isn't one, right? This is, like I said, if you're measuring train tracks, you wouldn't take your tape measure and measure like that, right? It wouldn't give you a true length or how wide they are apart. Okay? So, here's what's weird about this. If I gave you this, if I said this right here was 10 meters. Let me ask you, just raise your hand and let me know. Is it possible now? Right? Is it possible now? Is it possible to find the area? Who says yes? Raise your hand. Who says no? Okay, now I see people looking around at each other to see, okay, so that tells me that they probably didn't know. Okay, now I told you that usually, don't we usually see the height of a trapezoid? Don't we usually see it with a dotted line, something like this? Something like that?
Yeah.
Guys, let me ask you a question though. Is that a right angle right there?
Yes.
Yep. Is that right there going to be the exact same length as that?
Yep.
Yeah.
Let's check.
Oh my gosh.
So basically, what I'm telling you guys is, even though it's not showing it as a dotted line, is that still right there the height of this triangle, or this trapezoid?
Yeah.
Yeah, it is. So now, all you'd have to do is plug in 10. Now you're just going to evaluate it like that. 1/2 times 10, parenthesis, all that. And I think you end up getting 260, but I'm not going to worry about that right now. Okay? We're going to go on and do another one. Go. Find the area of this figure. Make sure you're doing the 3 points that I require. Go. Here we are finding the area of that triangle. I believe the answer is 28. Now, here's the good thing. Well, I'm not sure where 19.6 would have come from. I think, well, I might know. We'll see here in a minute. I definitely know where 56 came from. And this one here, I'm not sure. I'm not sure where that came from at all. Okay, so here's the deal. Guys, for the person that put 56, all they did was 10 times 6. They did area equals base times height. This is not a parallelogram. This is a triangle. So you've got to use the appropriate formula. Okay, you have to do area equals 1/2 times base times height. There's my first point, right? Now, I've got to figure out what the base is. Now, I'm going to guess that the person that got 19, I'm going to guess that they did 1/2 times 7 times 5.6. I don't know if that's true, but that's my guess. They are getting confused with what the base is for math and what the base is in real life. Is the base the bottom? Not necessarily. Can it be? Could be, but it's not necessarily it. By you guys saying that 5.6, that they don't meet at a right angle. Look, 5.6, does that meet at a right angle right there, guys? No. So 7 is absolutely a distractor. Is that what it was?
The 19.6.
19.6. That's the whoever did get that. You didn't. You used 7 as your base. Okay, that's a little bit confusing. You got to make sure you figure out where the right angle forms. The right angle is going to form right here. So that means this is your base, this is your height. So it's going to be 1/2 times 10 times 5.6, which is where we get 28 kilometers squared. Did I get my 3 points here, guys? Formula, answer, kilometers squared, right? We all got that?